What's up everyone? For today's video, we will learn about trigonometric identities. Without further ado, let me ask you a question. How can we prove that a trigonometric equation is an identity? From our previous lectures, we've learned that the 6 basic trigonometric functions include sine, cosine, tangent, secant, cosecant, and cotangent. But how are they related to one another? Well, to answer that, we need to identify the fundamental types of identity, which include the reciprocal, quotient, and Pythagorean identities. First, reciprocal identities simply show us that a trigonometric function is equal to one over the other. This include the following. Sine theta is equals to 1 over cosecant theta. Cos theta is equals to 1 over secant theta. And tangent theta is equals to 1 over cotangent theta. Meanwhile, to get the value of cosecant, secant, and cotangent in terms of the other trigonometric functions, we just have to cross-multiply and use the division property of equality. Hence with those, we'll have cosecant theta is equals to 1 over sine theta. Sec theta is equals to 1 over cosecant theta. And cotangent theta is equals to 1 over tangent theta. Second, the quotient identities. If in the unit circle, cosine theta represents the x component of the angle and sine theta serves as the y component, tangent theta, on the other hand, is y over x, or sine theta over cosine theta. Since we've discussed earlier that cotangent theta is the reciprocal of tangent theta, and sine and cosines are the reciprocals of cosecant and secant thetas respectively. Thus, the other quotient identity is cot theta or cotangent theta is equals to cosecant theta over secant theta. Lastly, for the Pythagorean identity, let's look at this triangle ABC as an example. As we can see, sine theta is equals to A over C by basing on the SOHCAHTOA from our past videos. Meanwhile, cosine theta is equals to B over C. Hence, if we try to add the squares of both sine and cosine, we'll have sine squared theta plus cos squared theta is equals to A squared over C squared plus B squared over C squared. By simplifying those, it would become sine squared theta plus cos squared theta is equal to the quantity of A squared plus B squared all over C squared. And what does Pythagoras has to say about that A squared plus B squared? That's correct. It is equal to C squared, based on the Pythagorean theorem. Thus, sine squared theta plus cos squared theta is equal to C squared over C squared, equal to 1. From there, we can derive the other Pythagorean identities. Let's try this out. Suppose we have 1 plus tan squared theta is equal to 1 plus tan squared theta, which clearly shows identity. Now let's try to manipulate the right side of the equation by using the quotient identity of the tangent function. We'll have 1 plus tan squared theta is equals to 1 plus the quantity sine theta over cos theta squared. By the laws of exponents, we'll have 1 plus tan squared theta is equals to 1 plus sine squared theta over cos squared theta. By constructing a single function on the right side of the equation, we'll have 1 plus tan squared theta is equal to cos squared theta plus sine squared theta all over cos squared theta. From this, we'll use the first Pythagorean identity to get 1 plus tan squared theta is equals to 1 over cos squared theta. Since 1 over cos squared theta is equal to secant squared theta, then we'll just have to substitute it. Thus, we'll have 1 plus tan squared theta is equal to sec squared theta. And also, the last Pythagorean identity, which is 1 plus cot squared theta is equals to cosecant squared theta, will be derived from those same processes. So, how can we prove that a basic equation is a trigonometric identity? Well, we just have to integrate the identities we've learned until we reach the point where the left side of the equation is also the right side of the equation. Like A is equals to A or 1 is equals to 1. And from there, we can say that it's an identity. Now, it's your turn. Try to determine and prove if the following functions are trigonometric identities. See you next time as Archimedes awaits you. subscribe to our channel, and click the notification bell to be updated for our next videos.